if you're saying that to add terms, like what we've seen in the past, you needed to have like terms, and those like terms would be the same variable with the same exponent. What do you think would be considered like terms with radicals? Brian?
It would be like the same radical, the same radicand, and the same, kind of root.
You could call it a root, same root, or index is the other word that I've been reading. So yeah, if the radical and its root is identical to a radical and a root and the radicands match, that would be like saying you have 2x and 3x. If you have square root of 3 here and square root of 2 here, that would like be saying x and y. So you're going to have to make sure to add or subtract radicals, you have to have a match. And I'm going to tell you, they're not going to give you a whole bunch of radicals that have the same radicand and just say, okay, go ahead and add the coefficients now, like you've done in the past. They're going to make you work a lot harder than what you've had to do in the past. So our objective today is to understand how to add and subtract radicals. And again, this actually does come out of, I haven't put the homework assignment up there, it does come out of one assignment. They put both of them together because addition and subtraction are so interrelated that you can take a subtraction problem and turning it into adding the opposite. So they don't consider it two separate things. So this comes out of lesson 11.6. Okay, so let's recap. To add terms, they must be like terms. So prior information that we've done, like terms, were same variable, same exponent. And when we recognize that's our situation, we would either add or subtract the coefficients only, variables and exponents remain the same. So in other words, and you've heard me say this before, something of the same variation, if I add 3 oranges to 2 oranges, I don't get 5 apples. Okay, that just doesn't make sense. But that's kind of mathematically what you guys tell me when you say 2x plus 3x is 5x squared. You've now changed the variables from being x's to being x squareds, which are completely different variables. So again, you got to keep things the same. So we would have 2x plus 3x is equal to 5x. Now, when do I add or when do I subtract? Well, you got to look at this operation and it tells you exactly what to do. So you follow those signs and you follow your integer rules. So when it comes now to this new stuff with radicals, so radical-like terms, we still have this notion of same, but it's same root, same radicand. Okay? That is a hard color to read, isn't that? Let me darken him up a little bit. Radicand. That's not much better. How about if I do this? Okay. Same root, same radicand. So the same process is we're going to add or subtract the coefficients only, okay? So you would have something like a radical x plus b radical x, that would equal a plus b radical x. So again, that's just an algebraic way, a generic algebraic way of explaining that. So again, that would be fantastic if all they gave us were like radicands and we could just add coefficients till the cows came home. Bummer thing is, you're kind of more advanced than that, so we are now going to have to put on our thinking caps how to deal with this. So, let me see if we are all ready. Are you drawing pictures, Connor? Are you ready? Okay, so don't draw pictures. So, here's the deal for us with radicals. Chances are you're not going to have matching radicands. You may have something like the square root of 3 and the square root of 12. Okay? And at first glance, you'd say, they're not like terms, so I can't do anything. Well, then pretty much every single problem off your homework you won't be able to do anything about if that's where you stop. Job 1 is to go back through your simplest radical form rules. We have 3 things to contend with. Number 1, are there any perfect square factors other than 1 left underneath the radical? If so, I have to simplify and factor it out. Okay, take its square root, get it out. 2, do I have any fractions underneath the radical? If I do, that's not okay. I'm going to have to try to take the square root of the numerator, take the square root of the denominator. If I end up with a radical in the denominator, I'm going to have to rationalize that denominator by multiplying top and bottom by that radical. All 3 of those things need to come into play on your homework tonight. So with radicals, number 1, simplify the radicals. That looks still bad. If possible. If you've got a square root of 3 and a square root of 5, there's nothing that you can do because you can't simplify those. So some of the things, I mean, just right here, remember your simplest radical form. And I'm going to write here SRF because that's what you hear me refer to. SRF, simplest radical form rules. Okay? So that's what we're going to do first, and then we're going to add or subtract depending upon what the signs tell us to do. The coefficients of the radicals with matching radicands. Sometimes we won't have matching radicands. Sometimes we'll have 3 terms and 2 of them will match, a third one won't match, therefore you don't get to do anything about that one. He stands separate proudly. Alright, so we've got a couple of examples. Let's go ahead and start them. Directions are going to say simplify, do all the math you can do until there's no more math to be done. We have 2 radical 7 plus 6 radical 7. So our job is to go and stare right here at the radicals. Are they the same? Can I simplify them? No. So all I do is pull out the coefficients, do whatever math the operation tells me to do, and that radical 7 is what remains. So I get 2 plus 6 is 8, and I get 8 radical 7. Okay? They're not all going to be this simple. Miles?
I have a question.
Huh?
I figured it out.
Okay, all right. 2 radical 3 plus 3 radical 3 minus radical 3. So our job, look at your radicals. Do they match? Are they the same? Can they get simplified? Anything to be done with them? Do they all match? Okay. If they all match, then it says take your coefficients and do the math it tells you. Now notice I have 3 terms, so I have to have 3 coefficients. The third one doesn't have a coefficient written out, so we know that anytime we don't see a number, it's always 1. And then we have a radical 3. So I have 2 plus 3 is 5. 5 take away 1 is 4. So my answer is 4 radical 3. All right, so here's another one, a little different from those, and then we're going to get into the real nitty-gritty. We have 3 radical 5 minus 8 radical 11 minus 7 radical 11 plus radical 5. So do I have all of my radicands match? No. Okay, that's a problem. I can't just all willy-nilly add them up together. Do I have any radicands that match?
Yes.
Yeah. In fact, if you noticed, I have some radical 5s, and then I have some radical 11s. So that's how I'm going to split this problem up, is taking the coefficients of the radical 5s. And honestly, the order doesn't matter. And then just generically, I'm going to put plus here, and I'm going to put the signs of my coefficients inside here, what I'm doing for the 11s. So I get 3 plus 1 is 4 radical 5, and negative 7, or negative 8, take away 7 is negative 15 radical 11. Can I combine 4 radical 5 and negative 15 radical 11? No, the radicands don't match, so that's where your answer stops. Okay? All right, so let's get into what you're really going to spend the majority of your time working on. Something that looks like this. So, do your radicands match? No. So the question then comes back, okay, can I simplify a radical here? And the answer is, oh my goodness, yes, I can. 8 is really 4 times 2. So radical 8 is really radical 4 times radical 2. So this had a 2 in the front, and the radical 8 simplifies into 2 radical 2. Well, 2 times 2 radical 2 gives me 4 radical 2. So it took me a little bit of prepping time to get this problem to look like the first couple that we did. So now I have my match, and I just pull out my coefficients, add them together, because that's what the operation tells me to do, and I get 5 radical 2. Okay? So, of the steps that should be shown, everything but the next to last step. Original problem, what you get when you simplify your radical, any product that you get from that, and then you don't need to show me that you're adding those coefficients. Okay, let's try another one. And we're going to do all sorts of different things. Radical 10 plus radical 2/5. Do we have matching radicands? Oh no, we so do not. Not ready?
Is it the printer in the teacher's room?
Yes.
Oh, it ran out of paper.
Oh, okay.
So it didn't finish.
Okay, so did they put more paper in?
I don't know. It's-
That would be great, thank you. Okay, so we've got a radical 10, and we got a radical 2/5. Radical 10 is pretty recognizable, so we don't have to deal with him. This is the one we're going to have to do some work on. So first off, it breaks rule 2. There's a fraction under the radical. So we split it into square root of the numerator, and square root of the denominator. This now breaks the rule 3 because I have a radical in the denominator. So how do I rationalize the denominator? What am I going to do? Miles? Yeah, so we're going to multiply radical 5, radical 5. So each one of them get multiplied by radical 5. Now this is where looking at how the book wrote their answers from last night kind of makes sense. Now I have radical 10 over 5. Okay. Now, do my radicands meet or match? Here comes the trick. I got to pull out the coefficients. So the coefficient of the first one is 1. What's the coefficient of the second one? 1/5. 1/5. That's why the book kind of got in the habit of writing their answers that way, because it's going to make a difference here. So there's an invisible 1 in front of the radical 10, and there was a 5 in the denominator. Okay, now, next little piece of information. You would never see this. You would never see a mixed number in front of a radical. So we're going to take that mixed number and change it to an improper fraction. So to finalize this answer, what would be the coefficient?
6.
Yeah. 1 and 1/5 becomes 6/5. Radical 10. So this answer now looks just like what the book was showing the answers from last night's homework. Okay? All right. We've got a couple more. You guys good? Let's do number 6. So 9 radical 7 minus 14 radical 1/7. So do we have a match? No, not yet. So we're going to have to do some work, and it's going to be on this guy right here. Now here's my word of caution. I really caution you that if there is a coefficient, that you keep the coefficient along with the problem. Because what I see happens is that kids will take the radical 1/7 and try to rationalize the denominator and then completely obliterate that there was a 14 in the front. So if you continue to keep it in the front, like that, then you won't forget about it, okay? The other thing you might want to do because of the sign is you might also want to carry along the sign, because that's the other thing I see kids do is that they'll turn this into a plus, okay? All right, so I can take the square root of 1. I don't technically need to show that, but you can see that, and then have this. Okay, how do I rationalize the denominator? What am I going to multiply by? Yeah, radical 7, top and bottom. So what I have is negative 14 radical 7 over 7. Am I done? Nope. 7 goes into itself once and into 14 twice. So where we're at is at negative 2 radical 7. Now I bring back in the front term. Now I'm ready to finish the problem. I had to take my time to get some prep done, and now I'm ready to do the actual math. So all I do is grab out the the coefficients from the like radicands, and I add them up. So 9 take away 2 is 7, and I get 7 radical 7. Ethan.
The 7 was negative and 1 was positive. Would you be able to do it or not?
If under the radican,
Yeah.
you cannot take the square root of a negative. Okay, not in our system. You will be able to do it in the imaginary system, but for us, no. So that would be, you can solve that problem. All right, we got 2 more. And again, we're getting into the doozy world. We've got 5 radical 3 plus radical 3/5 minus radical 5/3. Whew, that's weird. So not 1, but 2 radicals that I have to contend with. Fractions underneath, rule 2 being broken, so I'm going to split them up into radical 3, and I'll put a plus in front of there. Radical 3 over radical 5. Over here it's going to be minus radical 5 over radical 3. Okay, nothing that I can take square roots of. Both of them end up with radicals left in the denominator. So how am I going to rationalize the denominator on the radical 3 over radical 5? So top and bottom are going to get multiplied by radical 5. Okay, what about the radical 5 over radical 3? How am I going to rationalize that one? I'm sorry, somebody? I'm hearing them outside, not you inside. That's kind of scary. Multiply by top and bottom by radical 3. That notion of top and bottom by radical 3. Okay, so let's see where we're at. This one, radical 3 times radical 5 is positive radical 15 over 5. This one is minus radical 5 times radical 3 is radical 15 over 3. Now I can bring in this guy. Okay, are they all like terms? Do I have any like terms? Which ones are the like terms? The radical 15. The denominators don't matter to make it a like term. It's simply the radicands that matter. Okay, so guess what? The 5 radical 3 is just going to come along for the ride. He'll be in the front of the answer, but we're going to have to do some more work. So here we have 5 radical 3, and then we're going to pull out the coefficients. 1/5 minus 1/3 radical 15. Now what do we have to do? We go back to elementary school and we have to learn and remember how to add and subtract fractions. So what do they require us to do? We have to have a common denominator. What's the common denominator between 5 and 3? 15. So this first fraction, what did I multiply the 5 by to become 15? 3. So if I multiply him by 3, I multiply the top by 3, and I get a 3/15. Now there's a minus going on between these two, so let me put that back in. And then what do I need to multiply the 3 by to become 15? So I multiply the numerator by that, and I get 5. So that's still like that. All right, so here we go. We still have 5 radical 3, and then I have 3/15 take away 5/15, which is going to give me negative 2/15, and then radical 15. Now, can I simplify those 15s out? Why not? Yeah, they have to be the same, and that means they both either have to be under radicals or they both have to be not under radicals. This, dear folks, is your answer. Okay. Now, you could also write it as 5 radical 3 minus 2 radical 15 all over 15. You could do that too. Okay. All right, we got one more. So you're going to be working hard tonight. We have radical 6 minus radical 2/3 plus 5 radical 12. So right now, nothing looks good. None of it. Not one single bit of it. So we're going to have to do some extra work. Can't leave a fraction, so we're going to try to do this part to it. How are we going to rationalize that denominator? Multiply by top and bottom by radical 3. So then this gives me a negative radical 6 over 3. Okay. All right, let's look at this guy over here. Perfect square factor of 12 is 4. So I have 5, positive 5 times 2 radical 3, which gives me a positive 10 radical 3. And then I have a radical 6. Okay, do I have all matching radicands? Do I have any matching radicands? Yeah, the first two, right? The one with the 6s. So I'm going to pull out their coefficients. I have a 1 minus a 1/3 radical 6 plus 10 radical 3. All right, what's 1 take away 1/3?
2/3.
Yeah, 2/3. So I get 2/3 radical 6 plus 10 radical 3. And that's the best I can do on this problem. And then I'm done. Justin.
Wait, how did you get 1 and 1/3? 1 minus 1/3?
Because the coefficient of the radical 6 is a 1. The coefficient of the radical 6 over 3 is 1 over 3. Okay? All right. That's it.